Hi, everyone. I'm Natalie. Today I'm going to talk to you about a meta-analysis that I've conducted looking at the factors associated with heart weight and in egg and meat type chickens. Before I begin, I'd like to thank my advisor, my committee members, and my funding agencies for making this work possible. So, why do we care about heart weight in chickens? Due to intense genetic selection for meat yield, chickens grow at exponential rates. However, there has been a substantial loss in profitability due to premature deaths in chickens. Premature death is being reported as high as 6% across North America, which equals out to just over 1 billion chickens, which is a loss of around $100 million. The majority of these premature deaths are caused by cardiovascular issues, such as ascites or pulmonary hypertension. It has been hypothesized that higher breast meat yield has led to a lack in cavity size, which is limiting organ growth. This is therefore increasing the occurrence of cardiovascular issues. Livability traits, cardiovascular traits in particular, are of great interest to the poultry industry. These traits are essential for the well-being of the bird as well as the profitability and efficiency of the industry. The main objective of this meta-analysis was to develop a predictive model to identify the relationship between breast meat yield and heart weight. I chose to conduct a meta-analysis because a meta-analysis is a statistical analysis which combines the results of several independent studies for the purpose of integrating those findings. It was extremely necessary to identify the relationship between heart weight and breast meat yield across the published literature. To determine who to include in my database, I used a systematic search strategy across 4 different databases. So I used chicken or poultry, and breast meat yield, and heart weight, and genetic correlation, and aortic rupture or ascites. The literature funnel to the right of your screen shows the process I went through to determine which papers would actually end up in the final database. The 15 papers that were included in the final meta-analysis database had data extracted from them. The data I extracted included carcass component weights, organ weights, diet components, and flock characteristics, such as sex, strain, and age. The next step was to analyze the database and develop models. The model development and evaluation process is on the right of your screen. The generalized linear mixed model developed for this database was a y equals xb plus za model. XB being our fixed effects, ZA being our random effects. Our fixed effects were the interaction of breast meat yield and bird purpose, so egg or meat birds, or the interaction of breast meat yield and sex, male or female, plus age at slaughter in weeks. The random effect for this meta-analysis was study effect. The next step is model evaluation. RMSPE is a percent, and the concordance correlation coefficient were used to evaluate which model performed the best. RMSPE as a percent is a measure of precision, where smaller is better. And the concordance correlation coefficient is a measure of precision and accuracy, where the value of 1 means perfect agreement. So what does affect heart size? 2 models were run in this meta-analysis, Model A on the left and Model B on the right. Model A, interestingly, shows that female chickens, identified by the solid line, have smaller hearts than male chickens. The RMSPE percent for Model A is 5.7401, meaning there's about 5.7% error in the predictions. The conditional CCC value for Model A was 0.9859, meaning that the model's predicting about 98% accuracy. Model B shows a much more anticipated outcome, that egg chickens have larger hearts than meat-type chickens at similar breast meat yields. The RMSPE percent for Model A is 5.7656, meaning that it's predicting with about 5.8% error in the predictions, and the conditional CCC value is 0.9858, which means it's also predicting at about 98% accuracy. Both models predict similarly. However, for the purpose of this particular meta-analysis, Model B is our better predictor. So what did we learn in this meta-analysis? We learned that layer hearts are less influenced by increases in breast meat yield than broiler hearts. We also learned that male chickens are less influenced by increases in breast meat yield than female chickens, though this is likely due to the limited data set and how many female broilers were included in the population of that data set. Future directions of this project include expanding the database, including multiple species in that database, like turkey or quail, and then looking at multiple organs, such as lung and liver, as well as the heart. Thank you for your time today, and I eagerly await any questions you have.
Thank you very much, Natalie. If there are any questions from the audience, please go ahead and post those in the chat. I believe Brenda is going to be moving them over into Zoom so I can actually see them because I'm not on the Four Ways platform. A quick question from me. I noticed you, after you'd gone through the various literature sources, you shortlisted 15 from which to extract data from your model. Do you feel this provided a strong enough data basis for your model development? And on top of that question, how do you account for uncertainty in these kind of analyses when you're taking data from different sources?
So I think that obviously more data is always better. However, the general rule of thumb is if you can use 10 studies, then it's enough data. So 15 meets that criteria and even exceeds it a little bit. However, I'm hoping in the next expanded database that I have a plethora to pull from. As far as accounting for inaccuracies and hoping for consistency, we kind of just have to trust that they followed proper procedure. And do a lot of research in like understanding whether the groups that perform that research are well known for being accurate, or if there have been like some contingencies in the past that we have to take into account. But for the most part, we just have to trust that when they say they followed proper procedure, we did it again. And we also had a weight statement in the model that helped as far as like different population sizes. It kind of averaged it out where the mean was 1 so that we could look at it on a much more even scale.
Mm-hmm. And do you see a lot of noise or a lot of wide distributions in the data points that you're accessing from the different sources, or is it fairly tight?
As far as like the weights, they're fairly tight, but when it comes to our population sizes, they range from like 3,000 to 2. So that weight statement was really, really necessary to make sure that we could actually look at these accurately across the entire database.
Great. And I guess to add to your observation that, we need to trust that the researchers are doing their work well, we also have to trust that peer reviewers are taking their jobs really seriously and, making sure that we are all accessing really good science in the end.
Absolutely.